Hi guys, so today we're going to be looking at Chapter 3, Section 1, Solving Quadratic Equations. Let's start off with the first one over here. We're asked to solve quadratic equations using square roots. So, to do this, let's start off first with the problem on the left side. We have here 4x squared minus 31 equaling to 49. So to start this off, I'm going to get rid of the 31. Now I'm going to add 31 to both sides of the equation. Once I do that, I'm left with 4x squared equaling to positive 80. From here, I'm just going to divide 4 on both sides, and I'm left with x to the power 2 equaling to 20. Then, because I have a square, the opposite of squaring a number would be to square root. So the only way I can get rid of that power 2 is just by square rooting on both sides of the equation. When I do that, I'm going to be left with x equaling to square root of 20. And also remember that it has to be positive and a negative sign. We get here square root of 20, and that could be simplified by changing this into 4 times 5, and we get left with plus or minus, this would be square root of 4 times square root of 5, which is just x equaling to 2 square root of 5. Okay. Let's check out the next problem on the other side. And let me give myself some space to write down the other problem. So on the other side, I'm going to start off by subtracting 9 on both sides instead. When I subtract 9 on both sides, I'm left with 3x squared. This equals to negative 9. And then I'm going to divide 3 on both sides. When I do that, I'm left with x to the power 2 equaling to negative 3. There's going to be a little catch here though, because if I were to square root x squared on both sides, the only problem that I face here is that I'm square rooting a negative number. And if you remember from before, so I'll put this as recall, you can't really have a square root of a negative number. And the reason why is because square roots, they're the double of whatever is inside. So if you have the number 16, you would have here 4 times 4. Or negative 4 times negative 4. There's never a case where you're going to have a negative 16. And the reason why is because if I were to have a negative 16 inside, the only way to double a negative 16 is by multiplying negative 4 with a positive 4. But because, again, they aren't doubles of themselves, it doesn't work. So, because of that, and we'll put down right here that this just doesn't work, we're going to have to write down as our answer, no solution instead. Okay. Done. All right, let's check out the next problem. The next problem right here is asking us to solve equations by factoring. So right here, we're being asked to solve x to the power 2 minus 4x equaling to 45, and we have to factor that out. So right here, if I have x to the power 2 minus 4x plus 45, I want to first start off by creating the ax squared plus bx plus c format. right now, it's not in that format. Oops, sorry, that was supposed to be 4x equaling to 45. So at the moment, this equation right here is not in our ax squared plus bx plus c format. So what I want to do is move that 45 to the left side of the equation. So to do that, I'm going to subtract 45 on both sides. If I subtract 45 on both sides, I'm left with x squared minus 4x minus 45, and that equals to 0. Then from there, because I have my ax squared plus bx plus c format, I can identify my a value, b value, and c value, and then factor out. And if you don't remember how to factor, let's go through a little review. I'll go over one method of factoring, and then tomorrow's lesson, I will go over the second method of factoring. And it doesn't matter which one you choose to use, you just have to use either one. So this will be method number 1. If I were to factor out x squared minus 4x minus 45, I need to identify what my a value is, b value, and c value is from the formula ax squared plus bx plus c. From this, I know that my a value is going to be that imaginary 1, b is going to be -4, and c is going to be -4 as well. Or sorry, 45, not 4, -45. So right here, I'm going to write down a is equal to 1, b equals to -4, and c equals to -45. From that, I want to create my cross. And this is called the cross method, where the top numbers, a and c, are going to multiply together, and the b value is going to multiply down below. And I want to find two numbers on the left side and the right side that multiply together to get whatever this answer is, and also have to add together to get whatever this b value is. So if I were to start off with the a and the c first, we have here 1 times 45. And this is actually not 45, but -45. That equals to -45 here. My b value is equal to -4. So now I have the two numbers, -45 and -4. I need to find two numbers that are going to multiply to get -45, but add to get -4. If I were to think about it, if I use -9 times 5, that equals to 45, or sorry, -9 times 5, that equals to -45. And if I were to add -5 plus, or -9 plus 5, that would equal to -4. So because of the fact that they satisfy each other, that means I can use these two numbers, the -9 and the +5, down here. So that's what I'm going to do. I'm going to write this as -9, and this is going to be +5. And whatever those two numbers are, need to have the x values next to them. So when I write down my new equation, I'm going to take the first term from our original expression, so the x to the power 2. Then I'm going to take my two new numbers or terms, the -9x and the +5x. And the last one I'm taking is my c value, the -45. So the last term from the ax squared plus b plus c formula. So it's going to be -45. Once I do that, I can start factoring out the terms by x squared and -9x, and then factor out a term or a number from 5x minus 45. So For the first one, I'll take out an x value since they both seem to have an x. If I take out an x value, I'm left with x minus 9. From the other terms, I can take out a 5. If I divide it by 5, I get x equals to 9. And my goal here is to make sure that I get in parentheses the same numbers, set of numbers. So if I have x minus 9 and x minus 9 in both of them, then I know that I did my factoring correctly. So I'm going to merge those two together, the x minus 9, and whatever is left over, which is the x and that 5, I'm going to place them into their own factoring, x plus 5. And so that would be my final factor right here. So if I were to write this down underneath right here, my original statement, when I factor out x squared minus 4x minus 45, I get x minus 9 times x plus 5 equaling to 0. And from here, I'm just going to split it off into two different equations. We get x minus 9 equals to 0, and x plus 5 equals to 0. From here, I'm just going to solve for x. So I'm going to add 9 to both sides. On the other side, I'm going to subtract 5 to both sides. When I do that, I'm left with now x equaling to 9 and x equaling to negative 5. Cool. And so that would be my final solution. I would get those two answers. Okay.